All right, welcome to Unit 4. We're going to translate expressions between radical and rational exponents. So working with exponents here, of course, you've seen radicals before, and you've seen exponents, 2 to the third, okay? So nothing too crazy. And for the first lesson, we'll kind of just be reviewing some basic properties of radicals and exponents. Reminder, don't forget to comment. If you have a question, make sure that your question is very specific, and if you're answering someone's question, make sure that you are giving the correct answer. Also, make sure you watch the whole video because I may ask you to input something that you're unaware of at this point. And then one last reminder is that working hard begins now. All right, let's go ahead and take a look. First, I have just a couple sort of review exercises for you to do, and I urge you to go ahead and pause the video now, give all of these a try, and even if some of them seem a little weird, just think about what they're asking you to do and kind of move on from there, and we'll talk about these in about 5 seconds. So pause the video and try these on your own. All right, so let's start with 4 squared to the third power, okay? And I want to write this in terms of only one exponent. So if I think about this situation here, let's just pretend that we don't even know what's inside, what 4 squared is. If I cube something, that means that I'm multiplying it by itself 3 times. So I'd be multiplying 4 squared times itself 3 times. So if I were to think about this expression, what it's really asking me to do is to take 4 squared times 4 squared times 4 squared. And 4 squared is 4 times 4. 4 squared is 4 times 4. And 4 squared is 4 times 4. So I can think of this as being 4 times 4 times 4 times 4 times 4 times 4, which is 4 to the 6th power. And you maybe remember, right, when I multiply exponents that have the same base, those exponents will be added. You can see that that's the case here. So this is going to be 4 to the 6th power. And what you're going to remember here is the relationship is that when I have something to an exponent and then I raise that to an exponent, I am simply multiplying the 2 exponents to write it in terms of one exponent. So if I have a to the n, then raised to another exponent, m, I can simplify this expression as a to the n1 exponent n times m, whatever that is. Okay? Next, what is meant by these expressions here? So this would be the square root of 4, and I want to be really clear what that means. What do I mean when I say square root? What I mean is, what is a number that I can multiply by itself to get 4? Right? And in this case, I'm looking for, I only want to multiply that number by itself twice. Right? So something times itself, that gives me 4. So this is what's called the square root. This here is what's called a radical sign. Okay. This here is the cube root. It's a number that I can multiply by itself 3 times that will give me 9. Now, notice that maybe you've seen this before without the 2 here. Sometimes we write the square root without the 2. So if you see it without a number, that just means square root. If I put the number there, I'm specifying which root I'm looking for. Here I want the third root, meaning what's a number I can multiply by itself 3 times to get 9. Okay? And you may not know what that is, but that's okay. Right? The point is to realize that this is looking for the cube root, or what I can multiply by itself 3 times to get the number inside. Okay? All right, now I want you to simplify this expression. Hopefully you did so already. And so let's start. Remember, PEMDAS tells us to start inside the parentheses. So let's look. What is this? This is the square root of 9. So what's a number that I can multiply by itself twice to get 9? And that, of course, is 3. And then I want to square that number. Well, what is 3 squared? That's going to be 9. And what do you notice here? If I take the square root of something, and then I square it, I end up with the original value. Because think about what squaring means. It means multiplying by itself twice. So here, I wanted to find a number that I could multiply by itself twice that would give me 9. And then I multiplied that number by itself twice, and I ended up with the number that I originally started with. And so will this work for anything? So if I have the square root of any number, any positive number, right? I can't take the square root of a negative. Let's just work with positive. So any positive number, let's just call it x. And then I square it, what will I end up with? Well, I am finding a value, a number that I can multiply by itself twice that will give me x, and then I'm actually multiplying that number by itself. So I'm going to end up with just x. Similarly, if we apply this same idea to cube roots, so if I have the cube root of some number, and then I cube it, what will I be left with? I want you to pause the video and try this out. Hopefully you're seeing, look, what is this inside? Well, this is a number that I'm trying to find a number that I can multiply by itself 3 times that will give me x. And then I'm taking that number and multiplying by itself 3 times. So what will I get back? I'll get back x. Okay? And this is going to be true for any positive number. So this is the rule that we've just discovered, which is that if I take some number, x, and I take the nth root of it, no matter what that is, and then I raise it to the nth power, I'm going to be left with that original number. All right, so this is just a quick refresher on some exponent properties, and now we're going to apply this to talk about some different types of exponents. So we've looked at exponents where we have an integer in the exponent, right? Like 2 to the 3rd power. Well, what happens if we have a fraction in the exponent? So as an example, what do I make of 5 to the 1/3 power? It's kind of confusing. All right, well, what I want you to do right now is I want you to pause the video, and I want you to use some of the things that we just talked about to try and make sense of 5 to the 1/3. Okay? Give it a shot. Spend at least 1.5 minutes, 2 minutes, and then go ahead and press play again. All right, so when I look at 5 to the 1/3, I'm like, God, I have no idea what to make of this. But what I do know how to make sense of is when I have a whole number here, an integer. So I've got to think, okay, what could I do to this so that I make the exponent an integer? So what I'm going to do is I'm going to take 5 to the 1/3, and I'm going to raise it to a power. And I'm going to raise it to the simplest power I can think of that will transform this into an easy to work with situation. So I'm going to raise it to the 3rd power. Because what we've talked about is that if you have some number raised to a power, and then you raise that to a power, you multiply the powers. So we have 5 to the 1/3 times 3. Now, 1/3 times 3 is 1, so I'm left with 5 to the 1st power, which is, of course, just 5. So think about what that means. This number here, 5 to the 1/3, is a number that if I multiply by itself 3 times, I end up with that original number. Think back to what we spoke about just a few minutes ago. What else was a number that if we raised it to some power would give me back that number? Right? Well, the root, right? If I take, for example, let's imagine n were 3. If I take the 3rd root of some number, that's the number that I can multiply by itself 3 times to get that number. And then if I raise it to the nth power, I'm multiplying that number by itself this many times, so I'll get x back. Concretely, if I have 5 and I take the cube root of it and then I cube it, what must that equal? Well, it's got to equal 5. I'll put it over here. Think about this. So pause the video and think about why this is true again. This is saying take the cube root of 5. So find the number that I can multiply by itself 3 times to get 5. Then multiply that number by itself 3 times, and of course you'll get back out 5. Well, this expression over here also equals 5. So these two things are equal. And each time I'm taking something and I'm cubing it. Here's what I take and I cube over on the left side. And on the right side I'm taking the cube root of 5 and then cubing it. And each time I get the same thing. So what must be the case? Well, whatever I'm cubing, these two things must be equal. So 5 to the 1/3 means the same thing as taking the cube root of 5. 5 to the 1/3 means the same thing as taking the cube root of 5. So when I read 5 to the 1/3, I'm thinking, okay, I'm trying to find the number that I multiply by itself 3 times to get 5. I'm trying to find the number that I've got to multiply by itself 3 times to get 5. And this turns out to be true regardless. So let's take another example. Let's say that I have 4 to the 1/2. Go ahead and pause the video and try that. This would be the square root of 4. Okay. In general, we can write a rule for this. In general, we can say that any number x raised to a fractional power, so we're just working with easy to work with fractions like 1 over n, that is equivalent to the nth root of that number x. All right? And this probably makes much more sense if you think about a number being here, right? 4 to the 1/2. Well, if I square 4 to the 1/2, I end up with 4 again. Also, if I square the square root of 4, I end up with 4 again. So it has to be the case that they are equivalent. Okay? So this is another fact that we'll want to remember. All right, so now let's look at a situation where I don't have something easy like 1/3. What if I have 8 to the 2/3? Okay? And remember that we know what to do if we have 8 to the 1/3, right? So for example, if I had 8 to the 1/3, I know that that is the cube root of 8, right? What I can multiply by itself 3 times to get 8. And that, of course, is just going to be 2. 2 times 2 times 2 is 8. So how can I figure out a way? I need to at least rearrange this so I've got 8 to the 1/3 somehow. Well, 2/3 is awfully close to 1/3. In fact, 2/3, how could I write that in terms of 1/3? Well, 2/3 is 1/3 times 2. So I can rewrite 8 to the 2/3 is 8 to the 1/3 times 2. Well, remember our fact about exponents, right? Remember that if we have some number a to the n times m, that is equal to a to the n to the mth power, right? So look here, I have two values that are multiplied in my exponent, and I can apply this rule. So this is 8 to the 1/3 squared, because 1/3 times 2 is 2/3. And now I know what 8 to the 1/3 is. Right? I know that 8 to the 1/3 is the cube root of 8, and now I'm squaring that. And this I can get a hold of because I know what the cube root of 8 is. I know a number that I can multiply by itself 3 times to get 8. That's just 2. I'm squaring that, and 2 squared is 4. Okay? So this takes advantage of another key rule that we want to remember. And if I look back at this step over here and realize that I went from 8 to the 2/3 to 8 to the 1/3 times 2. So this reminds me of another rule that we'll want to make sure we have written down, which is that if you have some number to the a over b power, right, some fraction, that's the same as taking that number to the 1 over b power and then raising all that to the power of a, right? Because a times 1 over b is going to be a over b. So that's another key trait that we'll want to make sure we have in our toolbox to apply at any time, so that when we want to understand something like 8 to the 2/3, we can utilize these facts to arrive at a value that we know, right? Certainly if you said, hey, I want to, pay you 8 to the 2/3 dollars, well, you'd want to be able to know that that's $4, right? Hopefully that never happens. All right, so we're going to go ahead and look at a couple of problems. We'll try them out, and hopefully we'll be able to apply these nicely. One thing that I want to add is that it would be a good idea to write down these key rules that we have, that we've discovered, someplace really clear that I can go back and just look at them in case I ever have any questions. Okay? And it's good to have them with the example, but it might be a good idea to also have a place where I can quickly access them so that I can utilize them at any time. So right now, go ahead and just rewrite those rules nice and clear so that you have them ready for yourself, and then we'll be ready to tackle these questions. Here, nothing too crazy. Rewrite the expression below using radical notation. Of course, we know that that's a radical notation, right? And then evaluate the expression, so state what it is equal to, and you go back to your rules and you'll be just fine with that. And then here, place the correct symbol, either less than or greater than, in the box below and explain your reasoning. So in your comment, I want you to include your answer to this last question. Say, I thought 3 to the 1/2 was less than 3 to the 1/3. Here's why. Okay? Play around with them, understand what they mean first, and then give it your best shot. Okay?